Okay, so this is practice exam 1, and I'm going to start with, number 1. So in this first set here, we just have 4 plots, and then each of the questions just asks you which plot has which correlation. So first thing you can see over here is the first 2 correlations are negative, and we have 2 lines, or if you drew a line through these that are going in the downward side. And remember then, the closer to either -1 or 1, in this case the closer to -1, that means that the points are close to the line. So plot B is a lot more tighter to the line than is plot D. So we have those. And then the other 2 are definitely a positive and probably a positive, but pretty spread out around that. So plot C is going to have the higher correlation, or 0.89. So that's this one. And then plot A. Looks like, generally speaking, maybe a positive slope, but points quite scattered around the correlation line, or the regression line. Okay, the next 4 questions ask you to give you a series of means and standard deviations. As good as I'd like it. And so what I'm going to look first of all is at the means. And I want you to notice that 2 of the means are around 10 and 2 of the means are around 14. Well, clearly this is going to be one that's around 14, and so is this. And this is around 10, it's the middle, and this is around 10. So we've got the 2 over here are going to have means of around 10. And now we need to look at the standard deviations. The higher the standard deviation, the more spread out the data. So this one's going to have the higher standard deviation. So 6 is, I think that's A and B there. It's B. And then this one, 10 and 1.2 is going to be D. Same thing on the other ones. The other 2 have means that are in the same general area, around 14 or 15. Clearly C has the larger standard deviation, so just go and look at the standard deviations and get the one that's the largest for C, and then A has the smallest standard deviation around 1.2. Okay, on the next section here we have some box plots and histograms, and the task is to match those up. Okay, and there's a number of ways you can do this. I'm going to look first of all at B. It's clear that the one that's the most spread out. So all we have to do is go up and look at number 2. It's clearly the one that is the most spread out of the other data. The other ones are close to the same amount of spread. So anyway, 2 is going to be B. And when you see a graph like a histogram like number 1, that means that all of the points are in the two tails. In other words, the tails of the whiskers aren't going to be very long because Q3 is likely to be in this class. There's not going to be much outside of that. And Q1 is likely to be in this class, so there's not going to be much out beside that. So that's A. Not much of a whisker at all on those. Okay, so the other two, you can do this in one of two ways. You can note that the average of this one is going to be a little bit higher than the average of that one. And also, this one has skew, so it has more values in the bottom tail. And this one has outliers on both sides. And if you were going to have outliers in 3, they would have to be just on this side, not on both. So it looks like maybe this value and this value are outliers. So looks like those match up that way. Okay, moving down here to number 13. In a random sample of Russellville homes, the average number of trees in the home's yard is 4.4. The variable is, okay, the variable is number of trees in the yard. Be careful on this one. It doesn't really affect this answer, but the average isn't part of the variable. The variable is just what you ask each. So the number of trees, that's a quantitative variable. You can count them up, 1, 2, 3, 4. And since all you can do is count them, you can't have 1.38 trees in the yard. Since all you can do is count them, that's quantitative and discrete. And then in 14, we can't see all the responses, but I can see that the correct response is up here. 30% of Arkansans over the age of 30 have read at least one novel by John Grisham. So the variable is whether or not they've read at least one novel by John Grisham. So they either have or they haven't. I meant to underline the John Grisham, but I actually hit on the right answer there. It's a qualitative variable, and since there are only two categories, that's binomial. If there were more than two categories, you could have multinomial. So remember, qualitative variables just basically put things into categories, and you can get the percent in each category, whereas quantitative variables, you're either counting the number of items or measuring on some scale like length or weight or something like that. So number 15, we've got a random sample of 50 books. The average is 91.59. Is this sufficient evidence to conclude the average, or population mean I could have said, because that is from the population, it is under $100. So we want to know what the number 9159 is. Well, that came from this random sample. And so if you compute something from a sample, you have a statistic. In 16, we have a normal distribution with a mean of 260. I'm just going to go ahead and draw that out here. And a population standard deviation of 245. And it says what proportion of values are above 350. So here's 350 up here, and we're looking for the area out in this tail. Well, this distance is 2 standard deviations. You can just get the distance. We can compute that as z, although you really I don't think, need a formula when we're using the empirical rule, because you're going to be exactly 1, 2, or 3 standard deviations away. But you could just do x minus mu over sigma, and that's 350 minus 260. And what did I do here? That sigma was just 45, not 245, divided by 45, and that's equal to 2, as I said a second ago. Well, anyway, remember, if you go plus or minus 2 standard deviations, it says you have 0.95 or 95% of the data, but we only went in one direction instead of both. So this area here, I'll call it area A, is 0.95 divided by 2, or 0.475. And so all of this is equal to the 475. But let's recall, or hopefully by now you know, that from the mean up is 0.5. So this area in this curve is just 0.5 minus 0.475, which is 0.025, or D. So the next one we have still a mean of 260 and a standard deviation. This time I'll try and get it right. It's 45. And we want to know the proportion of values between 305 and 350. So we're looking for this area in here. So we'd like to know, well, so we're looking for this area, but we can only find this area and this area. And once we do, we can subtract and get the difference between those to get the area of interest. So I'm going to call this line A. And so for Z of A, if you want to do it that way, I'm not going to rewrite the formula this time. And we already know that it's that is 2 standard deviations. We calculated that right over here. And we already know that area A is 0.475. I should have just said 2 there. It is 2 standard deviations. The Z is the number of standard deviations. But it is 475. And so we'll call this area B. And so the Z for B, oh, that's not a very good color. Had to give it a try, though. This is area B. The Z for B is 1 standard deviation. You can just, if you want to do that, that's 305 divided by 260 over 45 is equal to 1. And recalling that if you went plus or minus 1 standard deviation, you would have 68% of the data. But we're only going one direction, so that's 0.34. And so we'll take that 475 minus 0.34 and get 0.135. Good, I have that as a response on there. How's that for a multiple choice? Okay, so in this question, we're just given a line really here, and we want to visually determine the slope and the Y-intercept. So let me also take note here that the X and Y axes are offset a little bit. See, here's 0. So if we did have the axis on here, it would go like there. The Y-intercept then is where this line crosses the line. So the Y-intercept, which is the second one there, is about 135. And so the slope then is the rise over the run. I'm hoping that you recall that from your earlier studies, although I say rise over run. Let's write that the correct way. So basically, I'm just going to pick a convenient number for the run. And given the numbers that I have here, I think I want to go from 40. Actually, I think I'll go all the way to 60. And then I'm going to go up and find where that is on the line. So I know this on my formula, that the bottom is going to be 40. And you can find any 2 points on there for that. And then I'm going to just go and see about where these are at. I'm not going to get exact, but close enough for what I'm looking at here. It looks like I'm going to say that's 95, and this is maybe around 5. So I'm going to say 90 divided by 40. Well, that's a little bit over 2, but of the numbers that I have over here, I have just a choice between 1s and 2s. And it's a minus 2. I should have said the rise really isn't a drop here, it's down. We're going from 95 to 5, so we're going this way, so the slope is going to be negative. And that was the first one on here, so we find negative 2 and 135. Be careful on the exam. I kind of am wishing now I would have done the Y-intercept first. You usually think of a line in terms of a plus bx. But just be careful and make sure that you are matching up the intercept and the slope correctly.